All right, so today's review day and obviously an assessment day. I assume we've made that clear many times. So yeah, we're just gonna I'm gonna go over some just basic class structure stuff because that's something that I assume you guys have a lot of questions on potentially. And then just do a quick example and then we'll open it up to Q&A. And then once you guys are done with Q&A, we don't wanna rush you, but we wanna have all time today to do it. We'll get you guys to your assessment after a short break. So I'm just gonna bring up a coding window and kind of start coding here. All right, so the example I'm actually going to use is hopefully you guys were able to attempt this challenge or complete it in week 1. It was the calculate mode challenge. This is where you're just trying to find the mode, mathematical mode of an input data set. So this is my solution. Again, I'm not going to go too much into the algorithm. Hopefully you guys attempted and discussed it previously, but this was my implementation of calculate mode. So my goal here is going to actually be convert this into a class so that I could use it maybe in a few different ways if I add more to it. And then I'm going to go through maybe hooking up a unit test to it and just making sure I test it thoroughly if I add more changes. So again, calculate mode. Hopefully you guys are familiar with the challenge. So don't worry about too much about the algorithm. I don't want to spend too much time on it because that's not my main goal here. But with that said, if you guys do have questions, definitely stop me. I don't want to rush through any of this. It's a live lecture, so just stop me if I'm going too fast or you have any questions. So I have this function. It works fine for my needs, but I'm kind of envisioning something in my head. So I actually want to convert this to a class and then maybe add more functionality and get the benefit out of a class there. So again, just to review, the first thing I want to do when I create a class is actually just use the class keyword. And I want to give a name to my class. So in this case, I'm going to call it mode. Nothing fancy there. And maybe calc mode, give it a descriptive name. All right, let me mute my Slack. Apologies for that. Okay, so I'm going to call it calc mode. Actually, let's call it mode because that's what it is. And so again, parentheses are optional here. In this case, we're not inheriting from anything, so I'm just going to leave them off. I'm going to put a colon. I always forget that in Python, but I remember this time. And that's just my basic class structure. So pass just means it's empty, and I have a class defined already. So if I wanted to create a mode object for my class, I could just say m equals, and then I call my class with parentheses. So this is actually creating a new mode object for me. But in this case, my mode class doesn't do anything. All right, so again, this is how I create my class. And this is how I create an instance of my class. All right, so I can create multiple instances. So if, for example, I want to create n equals mode. So now, in this case, I have 2 different instances of the same class. Note that this is different than saying something like, let me use better variable names. So this will be mode, and this will be, I don't know, let's call it mode 2. Not too creative here. So the mode and mode 2 are 2 different instances of the mode class. This is different than if I did something like mode 3 equals mode. Keep in mind that classes are not primitive types, which means if I do something like this on line 6, this is not creating a brand new copy of a mode class. It's actually just creating a reference copy. So in this case, mode and mode 3 are actually pointing to the same class. So if I made changes on like mode 3, that's going to be reflected in mode because they're pointing to the same exact object. As opposed to mode 2 is an independent mode object. So if I did something like create an instance variable like this is not going to impact the mode instance here that I created because it's a separate, totally separate instance of mode. All right, so again, understand what a class is, how to create an instance of a class, and understand what copying a reference versus creating a new object is actually doing in this case. All right, so I actually want to make my mode class a little more functional. So I have my calc mode method here. So I'm actually just going to copy that and then move it up here. And so it became nested, which means, sorry, my tabs are kind of all over the place. So I basically just took this, took the function I had before and moved it into my class. However, I am not done yet. If you guys remember the key thing about instance methods in classes, apologies for my poor speaking there, you always need a self parameter as the first parameter into your function. Again, this is a magic parameter, I would say, in terms of you don't manually pass it in, but if it's a class instance, if it's an instance method, the self has to be there. Otherwise, it's you're going to get errors when you have items as your first parameter. Let me just get rid of this. Items as your first parameter, it's going to expect that to be a reference for the object that's calling this method, and you're going to get a bunch of errors. It's not going to work as you expected. So in this case, always remember to have self as your first parameter for class methods. Now, as I've mentioned before, and just to highlight again, this could be actually, you can name this variable whatever you want. So if I wanted to call it whatever, this would totally work. I just got to make sure I use the whatever parameter when I'm typing out code. But just based on customs, you want to use self. That's the agreed upon terminology for the reference for itself. So we just use self. All right. So again, anytime you're creating an instance method, always have that self in there. Don't forget that, else you'll run into some trouble. All right. So I have my calculate mode method inside my mode class. This will take in items and calculate the mode, assuming my algorithm is correct. So let's actually test this out. So again, to create an instance, I'm going to create mode. Again, I can name it whatever. I can name my variable whatever I want. I'm just going to call it mode just because it makes more sense to me. And I create an instance. So at this point, I'm not passing anything in. And notice I have no init method. So init methods are optional. If you don't have any parameters to pass into your class when you create it, init you can leave off. It's not mandatory by any means. All right, so if I want to use this mode, we actually want to call the calculate mode method. So to call it, I use the dot and then call the function, the instance method on it. So this is calculate mode. Let me scroll down a bit. And let's just pass it some items. So I'm just going to create some items on the fly here. Maybe I'll clean this up later. I'm just going to type in some numbers. I'm going to make it numeric. I'm not going to worry about strings right now. Get an 8 in there, more 5s. Okay, so I just typed in some numbers, and looking at this, I think 5 is going to be my mode. So I have three copies of it, so that's what I should expect. So maybe this is where I'll write a unit test. So let's actually switch gears. Hopefully I'm not being too helter-skelter here. But let's talk about unit testing here. So I have this sample. Let me just run it to make sure it does what I want. So bring up my terminal, make sure I'm in the right file, clear this, and then so I can see my code. I'm going to run, again, to run Python, you type in Python, and then the file name. So it's my file is called hello.py, and nothing got printed. All right, so I'm going to assign my result to a variable and then print out that variable. All right, so hopefully, again, this isn't new information. You guys have worked with class before. All right, so my output was 5 because that is the mode. I have 3 instances of 5. If I had like an 8 in here, hopefully that would print out a 5 and 8 if I did my counting correctly. Yep, so both 5 and 8 are the mode in this case for this set. So I'm actually going to convert this to a test case because I actually tested it. I want to make sure if I make any changes to my mode algorithm, I want to make sure I don't break it via my test cases. And that's kind of the whole point of unit testing. So I'm going to jump to my hello test py file that I created before. And let's go through the steps of creating a unit test in Python. So the very first thing I need to do is import unit test. Now this is kind of like the magic in terms of this unit test module contains all the methods I'm going to use for unit testing. So I have import unit test. The second thing I usually do is actually insert that if statement. So I do, what is it? Name equals main, was it? Hopefully I don't have this backwards. So I do unit test dot main. Again, this is just from documentation. You have to do this. I'm actually not sure what main actually does. I think it just initializes the unit test framework. But you know, I would have to dig into the docs to figure out why that's needed. I just know that's needed. That's kind of the abstraction. I just call it and it does some magic for me, and I'm good there. All right, so I have those two things set up. Let me switch gears here. All right, so I have that set up. Let me, oh, I need 2 equals here. That's bad coding on my part. All right, so now I have the two things created. I have import, and then I initialize my unit test. Let me actually write my unit test class. So this is where classes come back into play. So class, and I'm going to give a descriptive name. So I'm going to say mode test cases. All right, so this is where we do have to inherit. And again, we haven't talked about inheritance too much, but know that this is how we inherit. We pass in the class that we want to inherit from. So maybe this wasn't made clear before, but this Unittest.test case is actually a class. So if you actually dove into like the test case source, you would see that test case is actually a class that has a bunch of methods and attributes on it. And that's what we're inheriting from. So basically, we're just borrowing everything that test case offers us here into our new class that we created. All right, so I got to put my colon here. And now I'm going to create some methods. And the methods are just the what the unit test framework is actually going to call. So I'm going to name it test. So usually you want to lead with a test underscore. And then let's say simple mode. Again, you always have to pass that self. Don't forget that self. It's easy to forget, especially because you're not manually passing it in when you call these methods. But just get in the habit of always having self as the first parameter within instance methods for a class. All right, so I have self. I don't think I need anything else in there. And then I'm going to do self asserts equal. Again, this is, again, VS Code will make it a little easier on you. It'll show you all the methods that exist on that class. You don't have to like necessarily memorize them. But again, there are a lot to know. So you might have to read up some documentation and how to quite use unit tests. But in this case, assert equal. I assume a lot of you guys, if not all of you guys, have used this before for unit testing. So that just is going to check if the two values I give it are in fact equal or if they're not. And that's what my test case is. So in this case, I need to import my hello py. So let's do from hello import mode, I believe is my class. So again, I'm importing the module is hello. So that's the name of my file. And the class name is mode. So that's what I'm importing for my test case. All right. So I imported my class. Now I can actually use it. So I'm actually going to create an instance of my class in my method. So let's say m equals mode. Hopefully that's not a poor variable name, but I kind of know what it is right now. So this is an instance I created of my mode class, and I'm going to use it in my test case here. So I'm going to call m, and then my function was calculate mode. Sorry, calculate mode, and then it takes in a list. So let me copy over the test case I actually created, since it's going to save me some time here. So maybe this isn't actually the simplest test case. So I might actually want to make this simpler. So I might save this for another test case. I'm actually going to copy this and create even a simpler test case because I just want to make sure I have a very simple test case. In case it fails, I could debug it easily. So in this case, I'm just going to have a, let's see, 5, 6, 7, 7, 4, 7. So in this case, I know the modes should be 7. That's pretty easy to see. Not too many values. I think that's a good, simple test case. All right, so assert equal takes in 2 parameters. It's going to compare those together. So my first parameter is this. And actually, it's kind of ugly to look at this. I'm actually going to break this out to a variable. So I'm going to say my mode equals the return value of this entire thing. So yeah, usually you don't want to nest too many function calls together. So I'm just going to break it out for clarity. So I'll do my mode here. And then I'll say, I'll make this even more clear. I'm going to say expected mode is going to be a list. That's what my mode function outputs. And I expect it to be 7. So here, I'm going to put my expected mode. So again, hopefully it's clear what this test case is doing. I have this assert equal. I'm comparing my mode answer, which is the result I get from my function, versus my manually, I guess, calculated mode, which is, in this case, 7. All right, so I have my first test case set up. I'm actually going to do that for my second one also. So I'm just going to do a quick copy paste because I think they're going to look pretty similar. And let's make this a little more robust. Let me borrow this again. So this is the case where I actually have 2 outputs. I added the extra 8 there. So let's call this, I could probably name these test cases a little better. But definitely want to have comments to anyone reading this code, even myself, to see what it's doing. So test if multiple mode values are returned. All right, so that's what this test case is doing. This one is just checking simple test case to see if a mode, a single mode value. All right, so always take that extra couple of seconds to add good comments to document your code. Again, this goes back to good code style. and making it easier to use your code in the future. Either if someone else is using it, or if you're looking at this code like 2 years from now, you want to be able to know what your functions or test cases are doing. All right, so I'm going to save that. I need to update my expected value. But all right, cool. So I have 2 test cases. Let's let me pause there. Any questions on unit test cases, creating them, anything I did right now?
The triple question quotes is because we're in this test mode class.
That's a good question. You could just write a comment here. I think writing it as quotes, the unit test might be able to pick this up. So when it's outputting stuff, you might have access to that comment. My apologies. I don't actually have a direct answer to that.
I think it needs to be the triple quotes as opposed to a comment. I think it calls, I forgot the exact method, but there's like a dunder method that calls whatever the doc is.
Yeah, it's the dunder doc method.
Yeah.
If you triple quotes will automatically assign it to the dunder doc method, I believe.
Gotcha. Thank you for that input there.
Thanks, everybody.
Yep. Thank you there. Yeah, that's good clarity, helping each other, helping me also. All right, so I have 2 test cases. So I'm going to actually just run them.
Anka, I've got a question. What about defining setup self? You don't need that in this test file.
Pardon? Could you repeat that question?
Setup.
So the setup method is only required if you want to like execute some code before each and every unit test.
Okay.
So if you want to instantiate a new instance and run that instance on every single unit test, you can do that instead of writing an instance of a class within every unit test. So you can use the setup method. So the setup method executes before every unit test is ran.
Yeah, so that's a good point. Let's actually try doing that. So if I do a def setup, I believe that's what you're asking about. I can actually create my mode instance if I wanted to in there. So I could do, yeah, let's actually use it, make this more class-based. So if I do self.mode and create an instance there. So I could create one instance that I'm going to use across my test cases. And that actually might make more sense if my mode is actually maybe potentially modifying values within the class. I might want to check for that. So if I do self.mode in setup, I think this is the way I would go about it. I could use self.mode in my test cases, so I don't have to create the same object twice. And again, this is something I may want to do, test the same mode module in multiple cases. So I think that's maybe what I want to do. Let's run the test case and find out what happens. So to run this file, I'm just going to do Python hello test UI. I got some errors if I could.
You have the.
Don't you have to initiate the function setup isn't going to run, right?
Yes. Sorry, I'm not familiar with setup, so maybe I shouldn't try using it. Apologies there. So I'm just going to default to using my mode instance because that's what I'm familiar with. So m equals mode capital S. Sorry about that, guys.
When you're passing in the list into calculate mode, you have brackets and brackets, so it's only counting that as one index.
Thank you, guys. Pair programming is great. All right, so I have that. Okay, so sorry, I'm kind of messing this up. Let me clear this. So I have my mode instance that I create in each test class. I pass in a list here, and then this is my expected output. So hopefully I pass my test cases now without syntax errors though. This is on line 4. Somehow I forgot my colon here. All right, save that, clear that. Okay, so I finally ran 2 test cases, got 2 dots, which means I passed them. So these were just 2 fairly simple test cases, but always good to kind of have that verify that your algorithm's working correctly. So I'm actually gonna go back to my source file now and actually modify my class a little bit to see kind of how classes might work for me. So let's say I actually want to extend my data to actually do, let's say, averages. I'm gonna rename my class actually and call it averages. And let's say I want to add in mode, median. So I'm going to do self and do a pass right now. And I want to do mean for good measure also. So do calc mean self. All right, so if I'm trying to figure out how I want to design my class, I'm actually going to look at what I have right now. So if I look at my calc mode method, I'm just going to shorten it for ease. I'm actually passing in some items here. But the way I have this envisioned is I actually want to just pass in some data, being a list of items, and actually be able to calculate the median, the mean, and the mode of that data set. All right. So one way I could do it is I could have all these methods taken in items, but usually I'm going to be wanting to do the median, mean, and mode for the same data. So if I kind of think about this, step back and just kind of get my game plan, I feel like I shouldn't have to pass in the items each time. Using classes, I could actually store that data internally and then just call these methods on that data, I guess, internally, rather than having to pass in the items each time. So this is where I'm actually going to introduce my init method. So we've talked about this dunder method before. Init, so you got to use 2 underscores. Don't forget that. If you have a typo here, as in 1 underscore or misspell something, init's not going to work the way you want it to. It has to be named init. This takes in self, like other instant methods. And then I'm actually going to pass in some items here. So I'm going to call items list just to make sure I know it's a list. And this is where I'm going to create an instance attribute. So that I do self and name it whatever I want. So I'll call it items in this case, items list. I like calling them list. And I'm going to assign what I passed in. And theoretically, I could copy it if I don't want to mess with the outside data. I could copy it. In this case, I'm fine. I assume the outside caller doesn't mind if I modify their list. Again, that's something I'm determining. I could definitely tailor this as I want to use it. So I created an instance attribute here. So again, this is creating a brand new attribute for the instance, and it's going to happen for all instances since I'm doing it in the init method. All right, so I'm going to pass in an instance list probably, and then calculate mode and mean. So in this case, I don't need to pass in an items manually. The reason being is that every instance that I create will have an items list automatically tied to it. So I don't need to keep passing it in. That kind of just makes it easier and cleaner in terms of my class has all the data internally. The external caller does not have to pass in additional data once it's initialized. All right, so I'm actually going to get rid of my items here. And now I know I need to use self.items list here. So just to be clear, in case it isn't clear, the value I create here is the same value that I'm accessing here. And the reason this is possible is because of the self value right here. The self is a reference to the instance that's calling this method. So for example, just for clarity, if I name this donuts here, again, not good naming, but if I create an instance donuts and called calc mode on it, in this case, I'll need to refine this. Basically, you can imagine, if donuts called this here, I could basically imagine that self is actually donuts here. So basically, the instance, if donuts is calling this method, self is just another name for the instance that's passing it. So if I wanted to imagine that this is donuts, I could do that. And that just kind of makes it clear to me that, all right, if donuts is my caller, that's actually what self is referring to. So that kind of makes it clear that donuts, you're calling items list on that instance. But in this case, we use self. We don't want to specify it to one caller. That's why we use self here. All right, so that's that. So I'm going to get an error here. As you can see, my mode is red underline. That's because it's expecting an items list in its constructor. So in this case, I'm going to move this list that I had before and move it in as a parameter for the creation of this object, because it's kind of required at this point. Let's rename this to not donuts. I don't want to think about donuts right now. All right, so this is a different approach to it. Instead of passing my list directly to the function, I'm going to initialize my class with the data, and then I can just call calc mode without passing anything to it, because the data that I had is already attached to that instance now via self.items list where I assigned it in the init method.
Question, Encore.
Yep, go for it.
So you showed us these 2 ways. Are you saying that the one you did right now is preferred over the other one?
It depends what you're doing. So when I had my first initial simple example where I just had calculate mode, in that case, I might not even need a class. Like I could just have a function that just calculate mode.
Right.
But I'm extending my functionality now where I want to calculate median and mean. So in this case, I would say, yes, it's generally better designed to do it this way, where you pass in the data once to your class, and your class will store it, and then your methods will act upon that data. As opposed to calling each method with the items manually. This is a little, I guess, poorer design, because now whoever created your instance has to each time pass in the items to your methods, instead of the class just having that data internally and can operate on it kind of just like behind the scenes, if that makes sense.
Okay, thank you.
But yeah, since I extended this functionality, I do want to store this data internally. That's the whole kind of the whole point of a class. The class is a package that could work kind of independently, and that the outside caller doesn't necessarily need to pass more data or do anything else extra. It could just pass in data and then operate on that data via the class interface. All right, so this will take in self.
It's the mode issue below that you renamed your class to averages.
You are right. A lot of renaming going on here. Yep, so let's just call this AVG, better clarity. All right, thank you.
Ankur, you're also missing a bracket.
Thank you much. All right, so I'm gonna actually implement my median, and median and mode are a little, or sorry, median and mean are a little easier. So to do this, I'm gonna take my self.items and then sort it. And then I want to grab the middle index. So let's say middle index. Again, middle index does not need to be instance attribute because it's only used in this function. It's not going to be stored anywhere, or it doesn't need to be stored. So I'm not going to create a self.middle index because again, it's not a value that the entire class needs to know about. This is only local to calc median. So I'm going to do middle index equals len self.items list, and then divide that by 2. So we're gonna do floor division. So this will get the middle index. However, if I have 2 medians, then I'm gonna need another middle index. So I might need an if statement. If self items list is that, sorry, not 1, we need 2. This is basically saying if it's even, as in we have an even number of elements. Now it's doing that. If we have even number of elements, then we want to get 2 values for the median. So we'll just do length equals that. All right, so this is the even case, and then this will be the odd case. So maybe I just want to store values here. So median, I'm gonna make that a list, and then it's gonna do the logic in here. So again, just to highlight Python, make sure you're tabbing correctly. I've seen some tabbing issues where maybe you have like too many tabs or not enough tabs. Like, you know, this probably will cause some errors if I try to do it this way. Like, make sure your tabs line up and make sense. They should be indented for each nested item they're in. So in this case, all of this logic is contained within my calc median class based on just looking at the white space tabbing.
Okay.
Questions out there?
Yeah, so the middle index, if we try to use it in another function, or like, do we have to add self dot?
For middle index, yes.
Another method, that's what I mean.
Say that again, sorry.
So if I want to use middle index in another method, do I have to, you know, write it like the self dot middle index? We are not using self dot here because it's kind of local here. So if I want to use it, let's say in calc mean, do I have to use self dot middle index?
Yep. So if you want to create a new new attribute that's tied to your class, as in it could be used by other methods, then yes, you want to do self dot. But it kind of depends how you're using it. If you know for sure you need a middle index, most likely you want to put that in your init method so it exists for any method, even if it's like none, if you don't know your middle index right now. In this case, we could probably compute it.
Okay.
But if you even don't know your value, you want to still create the variable so that if any other method accesses it, it won't like, you know, complain that this value doesn't exist yet. But in this case, if I put this here, and let's say, for example, my mean function, calc mean function needed to know middle index.
Mm-hmm.
If my logic
Mm-hmm.
down here called mean before calling median, this would not work because
Mm-hmm.
self.middle index would never have been created in that case where I call mean before median. So yeah, if you intend on, if you know you need a value in other methods, generally create it in your init method, as opposed to creating it in specific instant method.
Yeah.
All right, so in this case, for the odd case, I'm gonna just append the values for my list. So I sort my value because for median, I want to find the actual middles. I'm gonna just do this. So I have to do items, lists, and then find the middle. So the middle would be the length, which I created before, 4 division by 2. And then I also would need to append the next item in the even case. All right, so I think that should do it. Again, we'll test this. So I should definitely not
You
assume.
need a colon on line 11.
Thank you so much. I always forget those. All right, so I have that, and the else case is a little simpler. I could just do this. So not to get too optimizey here, I guess, but I can see I have duplicate values here, like this line and this line above are the same. So I actually can pull this out of my if statement because both cases, both branches of my if are gonna do the same thing. So in this case, I could append that value. And then if I do have the even case, I'll do some extra work, which is get the next value after that. All right, so this is where maybe comments might make sense. So I'll comment it. Make sure you comment your code when you're developing it. If we have an even number of items, get the next middle. All right, I forgot myself here, and got myself here. So always remember that self. If you create an instance attribute, you got to access it via the self. It's a common mistake. I make it all the time, as you can see, by just trying to get the variable directly. If I don't have that self, it's going to think that this is some other variable that I either created locally. It's going to try to find it locally. You need to access it through the self because that's where I've created that original attribute or variable.
In terms of having 2 middle elements,
Mhm.
It grabs the bottom one because of the floor division, right?
Yeah, so since we're 0-based index, the floor division will get us the actual middle in the odd case. So like, simple example, if you have 9 items, the middle index is actually 4 because we're 0-based, 0, 1, 2, 3, 4, 5, 6, 7, 8 for 9 items. So if we do the floor division, this will give us 9 divided by 2, which is 4.5, and round that down to 4. So 4 is actual middle index. And then in the even case, we need to get that middle index. So if we have 8 items, our middle index through floor division, I guess, would be -1. Good to check that. So if we had 8 items and we floor divided it, the middle 8 divided by 2 would be 4, which is one of the middle indices, but we actually want to get the one before it also in the even case. So thanks for bringing that up. So then I just want to return the median values from here. And then
would you want to maintain order? So do the if first?
Pardon?
Would you want to main order? So you would be doing the if first, then adding the other.
Yeah, I can see that. Yeah, that's a good point. If you want to have the items, I guess, in sorting order, makes sense. Good suggestion there. All right, cool. Thanks for the improvement feedback. So, pair programming, always great. Unfortunately, we can't do that for the assessment, but all right. So that's my median, and then my mean is a little simpler. I just got to sum up the values. I'm pretty sure I know how to do that. So I'm just going to do for n in self.items list have a sum value. So in this case, I'm creating a local variable sum. I don't need an instance method for it. So I'm just going to initialize that to 0, have my for loop, and add those values in, and then return that. Oh, I can't quite return it. I need to do sum divided by count. All right, so this will return a floating number if my values don't divide equally, but that's fine. That's what my mean is going to be. All right, so as you can see, I had an init method. I passed in my data at that point instead of passing into each function. Again, this is just better class design. You don't want to keep passing in the same data if you know it's going to be shared and reused. So calc median, calc with median, hopefully, calc mean, and then calc node. So let's write some test cases for this, and then we'll wrap up this example and obviously take any questions. So let me just get rid of this, and I'll just write test cases. And we'll verify that my median mean also works. So here in my mode mode answers. Let me do simple mean, and I have my objects. I'm going to do calc mean. I probably shouldn't have renamed everything, but sometimes you got it. All right, so I need to import averages because that's what I named my class. Change it here. All right, so my expected mode and my mode should be the same. I don't think I modified my mode method. Sorry for all the typing. I know it's not very helpful. All right, so I have my test case. So let me do a mean quickly. So let me just copy this from here. A dot calc mean. Let's make it very simple. I'm going to have 1, 3, 4, and 7. So I do a quick mental math. 3 plus 7 is 10, plus 5 is 15. So 15 divided by 4, that should be, I think, 3.75. Hope I did that correctly. If I didn't, well, I'll find out. All right, so I'm not going to create too many test cases. I don't want to take up too much time doing that, but I just definitely want to test the new logic that I added to make sure that that works. And then also I want to make sure I didn't screw up my mode, because I did change the way I access my function via a class. So I have averages, calc mean, 3.75. Hopefully that's correct. I'll find out shortly. And one more test case for median. Let's say 7, 7, 6, 7, 8, 4, 3. All right, so hopefully it should equal, I actually don't know what this should equal. Make it 4, 5, and 7. So in this case, my median should be 4, if I look at that correctly. So let me just put it out of sorting order to make sure sorting is working correctly. But my median should be 4. Fingers crossed that I'm not screwing anything up. All right, so assuming I have everything named correctly, I probably will get some errors because I don't trust myself, but let's give this a run. I need to rename this, of course. All right, so I have 4 test cases. I don't know if I'll pass them. I have indentation errors. We'll deal with that. All right, so I'm going to run my test case. Test simple mean.
Hey, Ankur, it looks like your line 20 indentation is off.
Thank
one
you.
space. There you go.
Yes. Always tricky. Still having issues here. Sure. Okay, so I ran my test cases. I got a bunch of errors on all of them. So something obviously went wrong because I'm not passing in data. That is the key change that I made. So again, my functions aren't taking values. My actual methods are. And again, my test cases aren't thorough in the case that I want to test mean, median, and mode. So maybe I'll write like a complex test case that tests all of them with the same data. So that's the reason I created that class in the first place. All right, so I passed my test cases. Let me create one more test case, hopefully not to belabor the point, and then we'll go to Q&A about this or anything else. So I'm just going to copy that test case, say test all averages. And then, so I'm going to create one average object and do a median, mode, and mode, and what's it? Mean. All right, so this hopefully will highlight the reason I created a class and kind of what the point of a class is. In this case, I don't have to keep passing the data all the time. I have my averages initialized with the data, and then my methods can just act on that data. So it kind of just makes it cleaner. I can just call these methods without having to worry about passing in data each time. And then yeah, so hopefully I could get the values I want. So expected median should be 4. Expected mean should be, let's do quick math. We have 9 plus 9 is 18. 19 divided by 5, that's going to be, what, 3.8, I think? Again, this shouldn't be a mental math exercise. It's more meant to highlight. And last is mode. So I guess in this case, we don't have a good mode, so let's add a 1 in there. Make my computations a little easier. This should be 4 and 5. Now this should be 3 and 4. Wait, 1, 1, 3, 4. Okay. And then my mode should be 4. That's going to be a list because it could be multiple values. All right, so hopefully that's cool. I'm going to chain these asserts. I'm going to do and so copy that, copy that, copy that. Hopefully this tabbing doesn't cause issues. My mean. All right, so hopefully it's clear what I'm doing. I'm creating a complex test. I can test multiple things if I want to. So this will kind of tell me if my complex doing all the checks actually works, or if maybe like my data gets modified in between. That might be an issue, and then I might need to figure out why all these don't work.
Does it have to be? Never mind. Oh, does it have to be nested like that?
Nested as in the tabs? No. I think this would work. I'm using a backslash, which lets you continue a line. Again, I'm getting some red errors here, so maybe I'm lying to you, but let's find out. So I have my last test case, test all averages. So hopefully this works, finger crossed. It might not work. All right, so luckily I got all dots. So this test case is definitely valuable because I'm actually using the class functionality where I use the same data and call multiple methods on it. So like hypothetically, let's say my mean method actually changed my data structure, like my mode would fail because it's using different data from what I expected. So that's a good test case there. Obviously, you could test a lot more things like having multiple, multiple data structures or more complex data input, but these are straightforward test cases in this case. So again, that kind of highlights how you use init. You want to pass in data that's going to be shared by your methods, and actually through the init method, save that as an attribute, instance attribute. Again, you don't want to do class attribute necessarily, because if I did something like this, if I did like items list master, I wouldn't want to necessarily do this because if I assign this the value I pass in here, theoretically, I could create multiple instances of this as I did before. Like if I want to do m equals averages to do some data set, like 6, 6, 7, and then I might theoretically have a totally independent data set that I want to do other stuff on. In this case, this wouldn't work as I expected if I stored it as a class attribute. That being because class attributes are shared. So this would be a bad idea, assuming I want to use averages, multiple times with different data sets. You don't want to store a master set because that would impact all your instances, not just the one instance that you created. So in this case, if I want to do something like calc mode, and of course brackets need to work like that, and like n.calc mode, like or calc median, whatever. In this case, again, if I only had a class attribute, these won't work correctly. Like n would fail, or m would likely fail because n would modify what m was working with in that case. So again, kind of be cognizant of when it makes sense to have class attributes and when it makes sense to have instance attributes. Again, the difference is class attributes are shared by all instances, so sometimes that makes sense. Again, in our dog example, for example, all dogs or most dogs have 4 legs, so you might just want to have that shared. If you have all those as instance attributes, that's actually a bad idea in the case where you have shared parameters. So like if I had a dog class and I created instance attributes for legs for all the dogs, sure, that would work. But then let's say hypothetically in the future, dogs get a genetic mutation, they all have 5 legs. I'm gonna have to go through each instance and update the force of 5s as opposed to just updating on the class.
For the unit test, is that test all averages just considered one test though?
Yeah, that's one test. Either, if my mean passes and my median passes, but my mode fails, that's actually what I want to test. I want to make sure that all 3 of these are passing. So yeah, that's one bundle. It's not 3 sub tests. It's it's either all or none. I want all these to pass, or if one of them fails, then my entire test fails. That's what I'm testing here. But yeah, so if you did want to have separate test cases with the same data, you might want to create an averages. Again, we create an init method here if you wanted to, and then have that data passed in. Again, I'm not quite sure how this works with unit tests, but we want want to just create a, averages up here, and that can be used by all these methods. Right, so if I want to just use the same data for all my test cases, it might make sense to create my averages here and just use this in all my, of course I need self. Don't forget the self. Very important. Bad example here. But yeah, so self.a, and now I could refer to self.a in all my test cases with the same data, if that were what I wanted to test. But in this case, I want to use different data to actually create that averages instance in my test cases. All right, so go for it.
For unit tests, you really, you can only test at the method level. So for instance, like if you wanted to make sure that your odd or even logic was working, could you break that out as its own method and then test that?
Absolutely. Yeah, so this is about making it more modular. So if I wanted to, sorry, you're saying for like a median case about odd or even?
Right, correct.
Yeah, so I'd probably, if I were doing this thoroughly, I'd probably have more test cases for like mode. I could have multiple modes, which I tested for, and single mode, but I didn't do that for median. In median, I only have a single here. But yeah, I would definitely want to be thorough and, add in another median case where I have an even number of values. I think I did that down here. But yeah, you want to probably have that separate as a separate test case. You don't want to just have one giant test case that tests every possibility, because that's not actually unit testing. That's testing, that's not units, right? Units are just concrete, smaller objects. But yeah, you want to have like simple tests that test individual functions, but then also sometimes combine larger use cases where you might call it multiple methods and test that also. But yeah, this can expand a lot. This could be way more thorough. I didn't do a great job with all the test cases I could have written, but I kind of just wanted to highlight creating classes and using them in your test case. Any questions on this example, or if not, we can move to just general Q&A for any other topics. So let's finish this up. Any questions on what I did here, why I created a class, kind of how I designed it?
Are we going to be able to reference this video on YouTube, or you guys can upload it after the assessment's over?
I will be uploading it, but YouTube takes a while. It takes like probably 15, 20 minutes to just process the video from Zoom, and then the upload can take another like half hour maybe. I will be uploading it, so maybe if you want to look at this halfway through the afternoon, it might be uploaded by then. But yeah, this is fair game. I mean, I don't think there's nothing revolutionary in here. It's mostly just review, so definitely should have access to that. But I'll try to upload it as soon as I can. All right, so classes, again, create a class with a class keyword. Make sure you understand why you want to create an instance attribute versus creating a class attribute. Again, in this case, I don't have any class attributes, but if I thought about it more, maybe it might make more sense to have something like, yeah, I guess one thing I just want to add, to belabor this too much, but like I could add a str method. Again, str will just make your printing of this object better. So in this case, I could print out, print calc self dot calc mean self dot calc. I guess I gotta return a string. Return.
Is it just organizing the way it's gonna print, or?
Yeah. So if I just said print, I'll show both examples. But this just makes it, I guess, makes my object better presented when I print it out to console. Versus if I don't have this, it's just gonna have a generic, non-descriptive printout statement, which I'll show shortly. But I just want to.
Yeah, if you don't do that, it'll be the memory address. So we'll say class blah 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 memory address.
Yep. So let me finish this up with median. Mode. I know it's kind of out of order. But yeah. So I have mean, mode, and median.
Would you encourage us to use this in the future, like just like presentation?
Yeah, str you will be using. I'm not going to say it's required for the assessment necessarily, but it is just usually when you create a class that's complex, having an str method is kind of a default. Like it's not going to break your code by any means, but usually you're going to be printing things out to like a web page, for example, and it's going to employ this str method. So it's kind of good just to have that by default if you think you're going to use it for display purposes. But
you'll be seeing it more next week.
Cool. All right, so if I want to just kind of test this out, I promise this is the last thing I'll do with this because we have other probably stuff to talk about. But let's just print out n in this case. So I have n created, and as my data set here, I don't know how to call these methods. It's going to be called from my str method. So it's going to do all the calculations. Again, notice that I don't have to pass in the data each time. So it makes it kind of easier for me. Formatting issues. Okay, cool. Let me just give this a quick run. So I have print n, and let's see what happens. So clear this, Python. That's not what I want. Python hello.py. All right, cool. So again, kind of seeing the benefits of classes, I just pass in data and I do a print statement. I don't know how to do modification myself. And this makes sense if I'm going to have like 20 different data sets I'm working with. I don't want to manually have to print them out myself. The str method is just one time I had to implement it. And now I get this like clean output of mean is some 0.1 or 0.0, mode is all these values. That seems correct because again, there's no majority in here. Let me just make that 9. All right, so my mean changed because I added an extra 9. My mode is 9 because I have 2 instances of that in my data, and my median is 7 and 8. It's an even valued, even number of data points. So that's kind of cool. You know, I could reuse this. I could kind of hand this off to Tom. I could say, Tom, I have this average module. Do you want to use it for your data? And he could kind of just use it easily. He doesn't have to implement anything. Everything is packaged inside my class, and he could just use this class right out of the box. He doesn't need to really implement anything. He doesn't need to really worry about anything. He just needs to know how to use it, which is pass in data and print out the values. So it's really easy for someone else using your code, or even if you're reusing it. That's why we create classes for reusability and kind of encapsulating everything into one package that is self-contained. All right, any last questions on this example? Else we'll just open it up and talk about anything else that might be on your mind. Actually, before we do that, let's take a quick break. So let's take a 8-minute break. We don't have too much to go over, but think about the questions you want to ask for review, and then we'll probably do another half an hour review segment and then get to your assessment. All right, so let's take an 8-minute break here.
Thanks, Ankur. This is a good option to show classes